Hello and welcome to our session on risk and return. Today we're going to look at the basics of risk and return. In the world of investments, you cannot run away from risk. Now, typically risk becomes bearable when you can get commensurate return to compensate you for the investment risk that you're taking. So when you have a good understanding of the risk and return trade-offs, then it becomes a very important tool that you can use in making your investment decisions at all levels. So for this session, we're going to introduce you to the computation of risk and return statistics for decision-making purposes and how to incorporate probability of state of economies into risk and return computations. Now, at the end of the sessions, you should be able to know how to calculate the returns on any kind of investment. You should be able to compute the variance and standard deviation of returns, and also be able to select viable investments based on risk-return trade-offs. So our outline is going to look at returns, basics of arithmetic mean, geometric mean, holding period return, and the issue of expected return. And then we're going to look at the basics also in terms of variance, standard deviation, and how to look into the risk-return relationship. Now take an investment, for example, that is undertaken today. At the end of the period, assuming it's a one-year investment, all things being equal, you're going to receive the ending market value of that investment, and if possible, for example, if you were to use stocks, the dividends to be received. For that reason, the sum of cash received and the change in the value becomes what your return in terms of nominal or CD or dollar terms. Now, in terms of percentage, then you're going to divide the sum of the full amount of cash or value received divided by the initial investment that you put up, and that gives you your percentage returns. Now, of course, the investment returns tell us the financial results of an investment. It's then usually the reason why we decide to defer consumption, so that the total monetary return we make is the income from the investment plus any possible capital gains or loss due to change in price. So let's take an example where you bought a bond for $9.50 a year ago. You received 2 coupons of 30 each during the lifetime that you held on to the bond. And today you can sell the bond for $9.75. So what is your total monetary return? We see that we made income of 60, that is 30 per each period or each collection period. So made a total of 60. And we made capital gains of 25 because we are able to sell that bond today for $9.75 even though we bought it for $9.50. When you put everything together, you have a total return of 85. It is normally more intuitive to think of your returns in terms of percentages and not necessarily in terms of monetary terms. And so when we look at it, our total percentage return can be captured as our dividend yield plus our capital gains yield. So then, let's look at another example where we have our CD return being that, and then our percentage return being that. So these are just examples to help clarify the situation. In some cases, you can make gains. In some cases, you can make losses, and these will be incorporated accordingly in coming out your returns. Now, it may so happen that you may hold an investment for longer than 1 year. Now, so for each year, you may make a return that is either declared or estimated. Now, if you want to know that at the end of the entire period, the entire investment period of N years or N seasons, what your total return is given as the HPR, which is our holding period return, meaning that it is 1 into each of the returns, the products of that, less the principal. And so that gives us our HPR. It tells us over the entire period how much in total return we made. Now, this is not per annum, but for the entire period. So if it's a 10-year investment, the holding period return will be showing you your 10-year return and not your average annual return. Now, so this is an example that we have where you have an investment for years 1 through to 4, and the returns are given accordingly as 10, -5, 20, and 15. To get your HPR, this is how you go about it. So then we have our 1.1, which is usually our 1 plus our 0.1, which is the 10%. And once we do the product of that and we take out the 1, which is our principal, it means the return after principal has been adjusted for is 44.21%. So the HPR in this scenario, given 10%, negative 5, 20, and 15%, is approximately 44.21. Now, when you want to look at average returns, and normally rates are quoted per annum, then we need to start looking at issues like arithmetic mean and also its alternative, the geometric mean. Now, for the arithmetic mean is earned on average over the multiple periods, and the geometric mean normally looks at the average compound return per period over multiple periods. Now, typically, unless the values are the same and the signs are the same, the geometric mean will normally be less than the arithmetic mean. So which is better? The arithmetic mean is usually quite optimistic for long horizons, whereas the geometric mean is overly pessimistic for short horizons. So barring any unequal values and changes in the mathematical signs, the geometric mean is usually preferred where you have unequal values and unequal signs within the same collection or the portfolio of returns that you're making. But if the values are the same and the signs are the same, all things being equal, the arithmetic mean and the geometric mean usually return the same values. Now, note that the arithmetic mean is not the same as the geometric mean. For the arithmetic mean, it's just the sum of the values divided by 4. On the other hand, when it comes to the geometric mean, this is what we have. We are going to take the product of the returns over, so that becomes a compounding return, and then we are going to take the in through. So this is a 4-year investment. We're going to take the 4th root, and then we're going to less the initial investment or the principal, and that gives us, instead of the 10.0 in the arithmetic mean example, we have a 9.58. And so these are where the differences begin to arise, and mostly due to the fact that there is a negative return in this collection of returns. So then this is what we have in reality for the geometric mean, and we can see that the geometric mean is closer to being approximately the same over the entire 4 years in relation to the HPR, whereas if we had used the arithmetic mean, we would have overestimated our total HPR for the same 4-year investment. Now, obviously, if you had 2 investments and they had the same return, you would be confused as to which one to take. Or in some cases, you have one investment earning or bringing in higher than the other, and then you may be a bit confused, but you should not be. The reason being that your final decision on which one to take should be influenced by the risk that comes with each of the returns you're looking at. And to look at that, you may have to consider the variance and the standard deviation, given typically in this case the standard deviation of the variance given as the summation of the variances across the units divided by the sample space less 1. Now, typically there is no universally agreed upon definition of risk. So for this class, we're going to look at measures of risk rotating around variances and standard deviation. Now, the standard deviation is normally the standard statistical measure that measures the spread of a sample. It tells us the spread about the mean, and that's what we are likely to use for most of our session. Now, its interpretation is normally facilitated by the discussion of the normal distribution, and so it tells us with what level of confidence we can take on the information that lies before us. So now let's take an example of how to compute the variance on a scenario. So here we have a project that already has an average return of 10.5, but then the actual return that were originally estimated, we had 15% for years 1, 9% for years 2, 6% for year 3, and 12% for years 4. So now we're going to look at the deviation about, that's the difference between the actual return and the average return. So here we have these values. If we net off in their raw format, we're going to arrive at the concept of no variation. However, to be able to pick out the real variation, we are going to square this deviation about the mean so that we can work with the absolute value. So in this case, the deviation about the mean is 0.0045. And then once we divide that by the sample space less 1, we have a case where our variance is 0.0015. When we take the square root of the variance to arrive at the standard deviation, we have a case of 0.0387. And so the standard deviation for such an investment, which is an average return of 10.5, is 0.038. Now, if you look at the risk-return trade-offs, what really happens is that for less risky investments like T-bills and treasury bonds, they normally don't have much deviations because they are not risky. But then when you look at large company stocks, that's private investments and small ones, you could see that whilst they return more in relation to, let's say, T-bills and treasury bonds, their risk profiles are quite higher. And then also small company stocks do return better than large company stocks, but they also have higher standard deviations. So now that is what you need to know as far as risk and return is concerned, and how you make use of that in your investment decision making. Thank you, and keep these questions in mind even as we prepare for the next sessions. So then you're going to look at which investments had the highest average return and the risk premium. And in this case, the risk premium usually captures the difference between the base return that you make for a riskless investment and the return you make for a risky investment. So normally, riskier investments should present or give you higher risk premium compared to lower risk investment. And then you should also know that risky investments typically come with higher standard deviation. Now, these are questions you should keep in mind and then prepare for our next session. Thank you.